each other out. So la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. So what does it mean to be free? To be free in this American dream. Oh, help me believe life is more what we've been told, what we've been told, what we've been told, what we've been told. So la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. Be free. What does it mean? La la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. I'm a slave in the darkness, alone in my apartment. I should have seen the warning sign. Money don't come easy, so most of us are chained to being busy till we can earn a little peace of mind. What does it mean to be free? To be free in this American dream. Oh, help me believe life is more than what we've been told it's supposed to be. Oh, la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. And it's such a mystery. We're still repeating our histories, even with the warning sign. Please help me out. Frustrated that this is the selfish world that we've been given. Oh, can we try and help each other out? So la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. Be free. What is it mean? Alone in my apartment, I should have seen the warning sign. Money don't come easy, so most of us are chained to being busy till we can earn a little piece of my mind. What does it mean to be free in this American dream? Oh, help me believe life is more than what we've been told it's supposed to be. Oh, la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. And it's such a mystery. We're still repeating our histories, even with the warning sign. Please help me out. Frustrated this is the selfish world that we've been given. Oh, can we try and help each other out? So la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. So what does it mean to be free in this American dream? Oh, help me believe life is more what we've been told, what we've been told, what we've been told, what we've been told. So la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. Be free. What does it mean? La la let, la la let me be. La la let, la la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. I'm a slave in the darkness, alone in my apartment. I should have seen the warning sign. Money don't come easy, so most of us are chained to being busy till we can earn a little piece of my mind. What does it mean to be free? To be free in this American dream. Oh, help me believe life is more than what we've been told it's supposed to be. Oh, la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. And it's such a mystery. We're still repeating our histories, even with the warning sign. Please help me out. Frustrated this is the selfish world that we've been given. Oh, can we try and help each other out? So la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. So what does it mean to be free? To be free in this American dream. Oh, help me believe life is more what we've been told. What we've been told. What we've been told. What we've been told. So la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. Be free. What does it mean? La la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. I'm a slave in the darkness, alone in my apartment. I should have seen the warning sign. Money don't come easy, so most of us are chained to being busy till we can earn a little piece of my mind. does it mean to be free in this American dream? Oh, help me believe life is more than what we've been told it's supposed to be. Still repeating our histories, even with a warning sign. Please help me out. Frustrated that this is the selfish world that we've been given. Oh, can we try and help each other out? So la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. So what does it mean to be free in this American dream? Oh, help me believe life is more what we've been told, what we've been told, what we've been told, what we've been told. So la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. Be free. What does it mean? La la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. I'm a slave in the darkness, alone in my apartment. I should have seen the warning sign. Money don't come easy, so most of us are chained to being busy till we can earn a little piece of my mind. What does it mean to be free in this American dream? Oh, help me believe life is more than what we've been told it's supposed to be. Oh, la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. please help me out. Frustrated that this is the selfish world that we've been given. Oh, can we try and help each other out? So la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. So what does it mean to be free? To be free in this American dream. Oh, help me believe life is more what we've been told, what we've been told, what we've been told, what we've been told. So la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. Be free.
Good afternoon, ladies and gentlemen. The Veterinary Technical Group of the UK Poultry Health and Welfare Group is delighted to welcome you to this joint poultry industry and government workshop on notifiable avian disease on the lessons learned during the 2020 and 2021 AI season. This is the third such workshop, with previous ones being held in 2018 and 2019. Of course, the current situation with COVID has necessitated that this one is held virtually, but we all look forward to getting back to live events in the not too distant future. We've had some 220 registrations, with approximately 70% of these being producers and industry persons. There's also excellent support from the veterinary profession and from government colleagues from across the UK. We've a great lineup of speakers whose expert knowledge on AI is second to none, and we will be making the presentations available after the event. We've allowed for 2 question and answer sessions and encourage you to ask questions using the website. You can submit these questions via the Ask a Question tab at the top right-hand corner of your screen. So I'm Mark Williams, Chairman of the Veterinary Technical Group and one of your co-chairs today. I will now pass you to your co-chair, Professor Christine Middlemiss, who is the UK's Chief Veterinary Officer.
Thank you very much, Mark. Good afternoon, everybody, and welcome to this joint workshop. I'm really pleased to be able to co-host this alongside Mark and the group, because it's really important that we all work together on learning what went well and what we can do better from the 2020-2021 avian influenza outbreak. It was a massive amount of effort, I know, on farm all the way through government and our exports and things, and we did a fantastic job and have a lot of positive outcomes. Particularly for me, that disease didn't spread onward from farm to farm. That was awesome. But there's still a lot of things we can learn. The threat has not gone away, as we'll hear from Ian Brown later this afternoon. And there's more we can do to help protect ourselves, our industry and our trade. And it's the really important part for me is that we've all come together to hear and share and can ask questions and take things home. So it's great to be able to do this. And I'll move on to our first speaker, who is somebody I have huge amount of respect for, work very closely with, and absolutely value his expertise. Professor Ian Brown, who is Acting Deputy Director of Scientific Services in APHA. Ian, of course, has a long history of being our UK national expert on avian and swine influenza and Newcastle disease, and is indeed our designated OIE expert for these 3 diseases. His Consultancy and expertise is really appreciated, not just by me and I know by our industry, but internationally. And that stands us in really good stead about knowing what early warning, horizon scanning, what's going on out there in the world of avian influenza globally, but also in building relationships with key trade partners, other scientific organisations, and so on around the world. So we have both the science to support the work we want to do and deliver in our outbreaks disease control as effectively and quickly as we can, and also the understanding globally of what's important in disease control and why. Enough from me just now then. I will hand over to Professor Ian Brown and welcome him as our first speaker. Thank you.
Thank you for the introduction. It's a pleasure to be here today talking to a good number of members from across industry and government on a very important topic that's continuing to be a major problem for the industry. So the story goes back to the middle of last year, and how can our international work help signal threat for the UK and the UK poultry industry? So we, the Animal and Plant Health Agency, have been working internationally with countries where perhaps these new strains of virus first emerge, persist, spread, pass into wild bird populations, and then they can be transmitted over very large distances. So the story of the 2020-21 epidemic goes back to the middle of last year when we found a new virus strain. Its origins were in the Middle East. We knew we had the right diagnostics, but we signalled then that we felt this virus was coming Europe's way. We couldn't predict how big or how major, but we knew there was something different in this virus that made it more dangerous. So this is the epidemic curve, and you can see that it's got a sort of a peak around the latter part of the year, and then the poultry cases are in red and the wild bird cases are in blue. And as normal, we can see that the wild bird cases precede and follow the poultry epidemic. So when the virus appears in poultry, we know that there have already been cases in wild birds. And of course, there was a much larger peak in cases in terms of total number from probably January through to about March. So here we have on the left-hand side the picture of Europe, the quite depressing picture of an exceedingly large epidemic in wild birds and poultry. And you can see here the poultry cases are in red spots and the purple spots are wild birds. And of course, there's a close association. The wild birds bring the virus and it finds its way into poultry farms. You can see that it was mainly a Northern Europe problem, but there are some clusters in places like Hungary and in France, southwest France, and that's where the virus is established in duck sector populations. This is due to a new strain of the H5 virus. This is the same virus that first came to Europe in the 2000s and has come back in many guises since. We call these viruses into family groups as clades, and this particular clade has been undergoing quite a lot of change in poultry and wild bird populations. So we know it was wild bird mediated. We know it came in with the migratory birds. We were able to map that through last autumn very clearly and carefully. And then, of course, we saw depressingly quite a large number of incursions into poultry farms, and in some cases it was spreading between poultry farms. Now, the good news, of course, in the UK is although we had 24 outbreaks, which is the largest epidemic we've ever had with highly pathogenic avian influenza, we did not see secondary spread between farms. So that is the great news. The not so good news, of course, is it found its way into a number of commercial farms in the first place. Yes, the virus does come in through wild birds, but of course it's activities around the farm that increase that risk through what we call fomite spread. So these are people, equipment, vehicles, all those activities on the farm are potential pathways that can lead to the virus breaking that farm boundary, the biosecurity boundary. When the virus gets in, it has a high lethality. It's 100 times more lethal in turkeys than it is in ducks and chickens. But ducks are even more susceptible than chickens. But that said, when chickens become infected, they rapidly get sick and die. So it's a very severe infection. We are seeing for the first time in the large epidemic multiple serotypes. So you hear these wonderful numbers, H5N8, that was a predominant strain, but we also had H5N5 and H5N1. But H5N1 is totally different to the virus that came to Europe in 2006. It's in a new guise, and we've seen other serotypes as well. And within those serotypes, there is so much genetic variation that we call new genotypes. Potentially each new genotype can cause a different wave of infection. So the risk has magnified immeasurably. And of course, in Europe, we used a number of measures to control, ranging from obviously the standard stamping out and with control zones to housing orders, but vaccination overwhelmingly was prohibited across Europe. Wild birds, of course, are the way we find this virus, and the UK wild bird surveillance found over 300 positive wild birds. That's the largest number we've ever had. And of course, this virus kills wild migratory waterfowl and other species, such as birds of prey at the top of the food chain. And that's how we track where the virus is and when it's arrived. Sometimes this virus gets into the so-called bridging species. The bridging species could be things that frequent farms. We don't think they actively get directly infected themselves, but of course they can carry the virus on their feet and their feathering and bring it into farm buildings where they have easy access. So controlling the access of these birds to your farm is very important. Now we look about season of risk. This is a map from EFSA, European Food Safety Authority, and they've tracked all the epidemics going back to 2016-17. And you can see the height is the number of cases and the width is the number of weeks over which we've had the epidemic. So the message is there isn't one precise window, although of course it's broadly from the middle of November all the way through probably to the end of February, middle of March. So therefore we've got what we say is a 30-week risk window. But of course we know if we use housing orders to reduce the risk of incursion of infection, that can only operate under current rules for 16 weeks. So there is immediately a dilemma where you place that. And that's why DEFRA take the science evidence and they make very careful judgments about when we use these housing orders. And that is indeed what happened in the UK this winter just gone. So in this map, you can see starting at the top left and going down and then through to the right, you can see that actually these are the epidemics over time. 16-17 was a very large epidemic. Then all the way through some years, very little activity, as you can see, small amounts of spots on the map indicating many fewer outbreaks. And then in early 2020, we had an unrelated event to the 21-22 outbreak. So, of course, the big question is, what will the shape of the next outbreak be? Do we think this is now a 3 or 4 year event, which it's perhaps been in the past? Or do we think that maybe we have to start preparing for a seasonal epidemic? I think depressingly, given the state of play at the moment with activity further to the east, we have to start thinking about this, unfortunately, being an annual event. Maybe not always on the same size or scale, but we have to prepare as an industry for an event that's not something that's going to be transient and over several years. So what we can do is map the virus and it changes at the genetic level. So this is effectively a family tree, and what we're able to show in the lilac color there, you can see that the virus that came to Europe in the early 2020, and then in red you can see the virus that came in late 2020-21. So what that's telling us is that we've got a new strain coming in, and that may give the virus increased vigor and ability to spread and infect multiple populations. Next slide, please. So this virus that arrived, we call it a clade 2.3.4b virus. Where did it come from? Well, I've already said, I think it came from the Middle East. It had probably been in poultry in the Middle East for some time. It then found its way into wild bird populations where it mixed with other strains that naturally occur in wild birds and produced a new virus again that was highly infectious, still retained high pathogenicity, but probably had very high transmissibility between wild birds. That virus still retained all of its characteristics to kill poultry, but was able to spread over a large distance through the wild birds. Not only that, we also saw these changing serotypes that I've alluded to. One point on the H5N1, that virus, being different to 2006, is not as dangerous. One good piece of news, that virus has adapted and changed. Its makeup no longer as dangerous, but we still have to be respectful and consider there is a zoonotic risk. Next slide, please. Of course, in the UK, we continually assess the risk, both through wild birds and poultry, and hopefully you use those assessments to inform your business making decisions around preparedness. We had a prevention order to restrict access of wild birds to poultry. That was the first step, and then that was followed by a housing order, which was enforced from December through till April, and you'll probably hear more about that later from my colleague. Industry cooperation in this process is vital, but you can see there from the map on the right-hand side that the H5N8 cases were in wild birds, and of course the triangles are the poultry breaks. And the most important thing to take home from that is we had cases from as far north as the Orkneys, the first time the virus had ever reached there, all the way down into the southwest and across into Northern Ireland. So this was dispersed across all of the UK administrations and presented challenges for disease control. We'd like to think that the measures that were taken in the UK meant that 24, whilst the worst outbreak we'd ever had, still mitigated from significant risk that was probably occurring elsewhere in Europe, where there were many more outbreaks. Next slide, please. So we know that wild birds are critical, and we'll go on to hear shortly from my colleague about what we can do at the farm level. And where are these key points? Where are the key places that enable, or practices that enable the virus to get into your poultry production system? We know that the wild bird pressure was unprecedented, extremely large numbers on a scale not seen before. We know the virus had a very, what we call high fitness, and we know that it was classically like a highly pathogenic avian influenza. We also know that ducks continue to be a challenge. Young ducks probably get very sick and die, but older birds can have quite a mild infection, and yet they're still shedding lots of infectious virus. Next slide, please. So each outbreak has its own characteristics. For instance, the virus that came in 2017-18 didn't cause really any poultry outbreaks, and we wondered why. It was in the wild bird population. Well, when we did the research at APHA, we were able to show that actually that virus wasn't very infectious. You needed a lot of virus, and it didn't easily transmit from ducks to chickens, which is what happens in the natural environment to some extent. So each time we get a new outbreak, we have to revalidate our assumptions. Next slide, please. Here we can see that, in fact, when we infect chicken layers, yes, we can infect them, but it needs quite a high dose. That may give us some clues as to why our free-range layers appear to be slightly less likely to get outbreaks than perhaps some of our other populations of farm poultry. Next slide, please. But when you do infect these birds, they show classical disease signs, and in fact, all of these spots show you that if you look at the whole body systems of the bird, you find the virus throughout the body, characteristic, of course, of highly pathogenic avian influenza, which, of course, ultimately leads to virus death. So then, was this the worst epidemic in Europe that we've ever had? Well, I think the answer is we haven't got all of the final numbers yet, but the suggestion is that it probably has been the biggest. In terms of wild bird cases across Europe, yes. In terms of poultry outbreaks, probably yes. And we know that according to the EFSA report, at least 22 million birds either died or were culled as part of the control effort. So this is, on record, one of the most devastating epidemics. And of course, the depressing thing is that when these epidemics are occurring in recent years now, they're seeming to occur on a much larger scale. So again, continual risk from new threat. Next slide, please. We know now the mechanism is that the new viruses gain access to wild bird populations, probably where wild birds interface with poultry, where the disease is not well controlled, and then they go to the far north. They spread amongst those wild bird populations that then migrate in the autumn, hence the fact that we get this virus coming to Europe down through these migratory waterfowl flyways. Next slide, please. This is the density plot predicting risk in wild birds and poultry. And if you look at the red areas, this is where the migratory waterfowl are. This is where they come into Europe. If you can remember back to that slide I showed you earlier, that's remarkably similar to where we got all of the poultry outbreaks. So there's no question, where you have high populations of migratory waterfowl and you have large populations of poultry, risk is much higher. Next slide, please. Of course, the key to this is to maintain good biosecurity and good hygiene practices. Make that part of your normal business, and I'm sure that's what many of you do. But I have a saying, the virus or the pathogen will find the weakest link. So any chinks in your armor. The key thing to remember here is that these viruses can survive in the environment outside their host for a very long time. So we track and monitor this through our research at APHA. We've known for many decades that influenza viruses survive very well in water, but they can also survive on pasture. Next slide, please. What we did was we measured the survivability of the virus that came in 2021 and compared it to previous epidemics. And the notable thing here is that each log of virus or each unit of virus could take 8.4 days at 20 degrees C or 21 degrees at 4 degrees C. Now let's assume we have 4 or 5 logs of virus. That's 4 or 5 multiplied by 21 days. That gives you over 80 days. So that means if a wild bird has deposited shed virus in its feces onto pasture, it could survive in that environment at 4 degrees C, the ambient temperature during our winter, for many weeks. Therefore, long after the wild birds are gone, you've got a risk at the farm door. And indeed, this virus, as you can see, has got higher survivability, twice as high as the severe epidemic we had in 2016 and 2017. Next slide, please. So, of course, there's a whole range of measures here, and industry colleagues working together. These are standard good practices, but of course, it's how well we apply them and how we manage and maintain them. Next slide, please. A few words about vaccination, because we often get asked. The challenge here is there are multiple families of H5 viruses across the northern hemisphere that create risk. So each one of these green blocks on the right-hand side in this dendrogram is a separate grouping of virus. And the likelihood is that vaccine to one of those family groups might not adequately protect against another one. We're having that debate now about COVID, aren't we? And influenza is no different. So the question is, what's the next risk virus? Which vaccine strain do we make? Next slide, please. Very complex diversity of viruses. And of course, it's a contentious subject, but inadequate vaccination that doesn't adequately protect birds might actually drive further virus diversity. So it needs to be done in an effective manner. Next slide, please. So what we've been doing at APHA is taking these new field strains that came to Europe, and we've been comparing them to vaccine strains that we know are used in other parts of the world as a standard control measure. And what the map at the bottom shows is the further the gap between the circles, the less likely a vaccine might protect. So on the left-hand side represented, we have the current field strains, a whole range of them associated with H5N8, H5N5 across a wide area. And then on the right-hand side, we have some of the vaccine strains that are in use in Central Asia as a routine measure to vaccinate poultry. You can see we've got a protective distance. So those vaccines, we would predict, although they would induce immunity in the bird, that immunity would not be sufficient to recognize the new field strains. And therefore, it may reduce clinical disease and severity, but it won't stop infection and it won't stop transmission between susceptible birds. Next slide, please. Therefore, we know what's driving this is there are key changes in the virus at sites that dictate the virus's ability to escape vaccine immunity. We may perversely select for some of these changes in the vaccinated population because it would favour the virus that has changes in those key sites. Of course, the good news is that only a proportion of these viruses that escape vaccine immunity may actually be what we call fit, able to spread between populations into wild birds and beyond. But we do know that many of these viruses are being maintained in poultry populations in some parts of the world where they do not have the tools or the ability to effectively control. And that creates a continual breeding ground of risk for poultry populations much further a threat. So finally, zoonotic risk is something that we also need to consider with these viruses. If we look at the H5 viruses, the top dendrogram shows human cases over time. The good news is, in general, there's been a slight slowing of cases, but the number of human cases is proportionate to the number of cases occurring in poultry. It also requires, of course, the right genetic makeup of the virus, and I've mentioned that already, that not all strains carry equal risk. But the H5N1 viruses that first emerged in the early 2000s have a case fatality rate of 53%. That's obviously exceptionally high. Of course, the good news is that these viruses lack the ability to spread from one human to another. Now, earlier in late 2020, there was a very large outbreak on an exceedingly large commercial unit of over 1 million birds in the Russian Federation, and there were 7 reported human cases. We think they've probably been exposed to high amounts of dust, and it couldn't really be established that these people were fully infectious, and it was an unremarkable infection, and they all recovered. But it was a salutary lesson to remind us all about the importance of wearing PPE and compliance with that, and that we have to treat these viruses with respect. So we continue to monitor the changes in these viruses, but H5N8 itself, that is the first reported infection in the Russian Federation. Does that mean that this virus might be changing? Should we be concerned about that? We need to continue to be vigilant. Next slide, please. What we do is every time we get a new epidemic in Europe or beyond or in the UK, we look at the genetics of this virus and we assess it for changes that might make the virus more able to infect humans. We also look at the potential for food safety issues as well. And so we're able through that work to very rapidly communicate to stakeholder groups through public health and through Food Standards Agency and through DEFRA about the risks and the safety of these viruses. So the good news is we can take the genetics apart now within hours and days of new outbreaks and get very good messages out there, which hopefully put a balance and assure that there isn't human health risk when there genuinely isn't one. Next slide, please. So I think to sum up, we're at a continual risk of what is happening well beyond our shores. A new virus did emerge in the Middle East during 2019 to 2020. That virus entered into wild bird populations, and those wild birds carried the virus over long distances. I should also add, since the big Euro epidemic, this virus has also found its way down into Africa, right into the Horn of Africa, into Central Africa, and into West Africa. So we have a continuing problem in that part of the world as well. We know that in areas where there was an inability to properly maintain farm biosecurity, there was lateral spread. I haven't gone into detail, but some farms in some of the North European countries suffered significant secondary spread, showing there have been some fundamental failures in their biosecurity, but thankfully not in the UK. We need the right tools to diagnose. That's why we work internationally to make sure we've got the right tests so we can protect the industry as best we can with the most sensitive tools. The virus can be maintained for very long periods. And this is a really key take-home message for those of you thinking about your biosecurity. Assume at your farm gate or just outside the perimeter of your production unit, the virus could be sitting in the environment for many weeks. So you need to think carefully about anything that accesses those areas and moves into the confines of your production system. Traditional vaccines, we think may have very limited effect. And until we get an international strategy to combat influenza through vaccination, we're probably going to still suffer the same problems. I have to say, though, probably to resolve this problem on a global scale, vaccination will become an important tool to reduce the effect of infection and allow us to get back to it being in a more manageable state. But there is a zoonotic risk, and we need to continue to be vigilant that changes that might naturally occur in the virus do not inadvertently increase the risk to humans. And of course, there's an increased sensitized community at large now about such risks. So we need to be vigilant and we need to prepare. So I think my final message to you is don't think about this as being a 3 or 4 year cycle. Just because we had infection last winter, we're seeing events happening to the east right now that mimic. I can't say with certainty there'll be another epidemic this winter, but I would say that we need to be prudent. We need to look at the lessons learned from the last epidemic, and we need to think of each of you as a business. Can we do things a bit better? Because at the end of the day, 24 cases was the largest outbreak we've ever had in the UK. And I think it's about through a workshop like we've got today that hopefully we can secure our sector as effectively as possible and learn from the past. Next slide, please. Many people contributed to this work. I won't go into them all individually, but to mention out a couple of colleagues, Reen Hansen and Ash Banyard, who ably led the national laboratory at the APHA and provided all that science evidence and, importantly, very rapid diagnostics and surveillance to help us control the infection. To our funders, of course, to DEFRA and the devolved administrations, but we also still secured money from the European Commission and work with our colleagues there to gain good intelligence, notwithstanding our international partnerships. Next slide, please. So thank you for your attention. We have a website there that we're refreshing at the moment, which will keep up-to-date information. If you have any questions at any time about the science and the technical aspects, we do have a generalised mailbox, so please feel free to use that. Thank you for your attention.
Excellent. Thank you, Ian. That was absolutely fascinating. And I'm sure people can understand now why Ian and his whole team are such an incredible and valuable part of our approach to preventing and then combating avian influenza. One of the key take homes for me for that is the risk never goes away. There's an ongoing incursion risk. Of course, it peaks through the winter, but with the ability of the virus to survive on farm for so long and our background risk, we all need to be vigilant 24/7, 365 to keep on top of this virus. Mark, interested to know, what was that standout message for you?
Exactly that, Christine. And to be perfectly frank, I've sort of been sharing my thoughts with our guys in the egg industry that, what Ian very clearly said is that we can probably expect to get clobbered again this autumn. And that's quite a frightening scenario. We have been used to sort of 3, 4, or even 5 years sort of windows, if you like, but it then leads on to other issues, some of which are policy issues as well.
Yes, absolutely. Thanks.
Okay, so ladies and gentlemen, we will move on. And again, just as a quick reminder, you can ask questions of your own via that ask the question button in the top right hand of your screen. So our second speaker is Andy Patterson. Andy is a veterinary epidemiologist. He's head of the APHA field epidemiology team and also head of the UK National Epidemiology Emergency Group, which together are responsible for investigating disease outbreaks in Great Britain. He's a European College recognised specialist in veterinary public health and a Royal College recognised specialist in epidemiology. After leaving UK farm animal practice in 1991, he joined PAN Livestock Services and the Veterinary Epidemiology and Economics Research Unit based in Reading, and since then has worked on livestock disease control projects across Latin America, East and Southern Africa, the Middle East and China, and carrying out work on behalf of international agencies and national governments. Believe it or not, 20 years ago, while waiting for a post to Uganda, Andy temporarily joined the Ministry of Agriculture, Fisheries and Food for the 2001 foot and mouth disease outbreak and still has not made it back to Uganda. And I guess the rest is history. Over to you, Andy.
Hello. Thank you very much for inviting me to talk to you about biosecurity issues we've experienced in the last few months. The team I run is very much focused on investigating the disease outbreaks and bringing together the science and field information to inform policy. So what we're going to look at are the factors that increase the likelihood of infection coming onto the farm, and those factors that increase the impact on your business when you become infected. Now, I like to just summarize the points that we're going to go through in the presentation so they flag for you as you go through. I mean, this really isn't rocket science. This is all about basic practices and doing them well. Now, we've got this system called Verdo, which I'll explain later, which helps us analyze the risk factors I'll talk about. And when we talk about the risk pathways, we're not expecting the sort of containment that we have in our specialist laboratories. We're wanting practical measures that will help control the infection on your farm. And it's useful to keep in mind the sort of lessons that you took for granted during COVID. And one of the things I want you to remember is that only tiny doses of virus are needed to come onto your farm, because you've got this susceptible population that will then amplify it. So it's a bit like petrol and a match all being okay separate. Bring them together, then you get the problem. And the difference is your population will actually amplify whatever came on. And for that reason, you shouldn't rely on your hard outer shell, your out perimeter biosecurity. That's something I've had brought up with me recently. People say, well, we've got this really good, very good system about stopping people getting on. Well, we'll talk a bit about why that really isn't enough. We're going to bring in the top 10 issues that we've identified. There are actually a few more. And we're also going to talk about the things we can do to help each other, the industry and government. And you need to, do biosecurity best. This is why it's so difficult when you don't have the disease. So you don't actually know that it's actually done anything for you, because nothing happens. This is always a problem when it's successful. And also, just to make the point that biosecurity isn't just for exotic diseases, it also is really important with endemic diseases such as Salmonella. One of the key issues for us is licensing, and for you during an outbreak. It's key to minimizing the impact that a disease outbreak has on your business. Now, basically, you've got to bear in mind that licensing permits you to do something that at that time is otherwise illegal under disease outbreak conditions. And biosecurity is key to you satisfying those licensing conditions. It depends on evidence, and it depends on trust, and it's based on risk assessments. And I think in summary, there are no easy answers. Good biosecurity requires real effort to do properly. So a general summary of the 2020 outbreak. All of the IPs in the current outbreak were attributed to direct or indirect contact with wild birds. There was no evidence of long-distance spread between premises in this outbreak, apart from where the premises were located close together and they were part of the same business. And you could see that within those premises, although they were part of the same business, they were separate, and there were movements that occurred there that meant that disease transmitted when perhaps it didn't need to. Often as well, we see that if you look at all the components that are present on a farm, they're all there, but they're just not very well done. And one of the lessons is that if you're going to do them, you've got to do them well. It's a bit like when it's your own business, your own home, you don't notice that dripping tap at home. So you need to go back and look at your business with an external pair of eyes and that sort of mindset. And I think to give you an idea of what we saw when we looked back across our data was that of all the commercial infected premises, not the backyard ones, but the commercial ones, 10% were good, half of them were pretty average, 40% of them I think were unimpressive, I think would be one phrase. So one of the things you need to think about the pathways that the disease gets onto your premises. They go into your gate, and you can control that gate completely. They come through the air, and we're thinking fecal contamination from wild birds here, and they can come over or through a fence or a wall. Probably less significant for bird diseases, but more important for some of the livestock diseases. And I think it's important, like when we talked about the hard outer shell, that you must think about each individual shed in the same terms. Don't assume because you've got a hard outer shell that that's going to protect you. Some countries offer that type of approach to national biosecurity, and it has let them down in the past. So you've got to not only keep the disease out, but you've got to stop it coming in and then being spread between the different parts of your business. Note the detail of this slide isn't important, but I talked about the risk pathways. This is simply the risk pathways to do with ABP. It's not the London tube map, although it looks like it, and it's actually a very simplified version. It's to make the point that risk pathways in a big, modern, integrated business are really very complex. And again, this point about a tiny infectious dose. The infection has got to come in, it's got multiple entry into your business, but it's got to reach a susceptible bird. There'll be plenty of times that virus in this last few months has come onto premises, but it's never managed to reach the susceptible birds on the premises. And this is always the weakest link. I think if we look at the things that stand out, entrances are often one of the poorest things. And I think the important thing about entrances is that, in effect, this advertises the expectation standards for your business for biosecurity. It's a bit like still wearing a face mask for COVID. Not only are you protecting yourself, you're making it clear to people that this is my acceptable level of risk. I'm still concerned, and I don't want you to do things to endanger me. So the key issues, so this was a top 10, but we ended up with 13. They're not in any order, and they're not grouped in any way. It was just as they came out. So bedding management is significant. The general maintenance and design of buildings, the location of those buildings near coasts and wetlands, the management of the business and the controlling mindset, your record keeping, making sure that when you do disinfection, you do cleansing first. Flooding was an interesting one. This time it's come up before, but it came up again. PPE discipline amongst staff, including managers, the presence of ponds on site and in the ranges, the access by vehicles, and having separate premises under the same management in close proximity. The other thing to think about is the co-location of infrastructure for the resilience of your business. I mean, many businesses grow organically, but what happens then if you're subject to restrictions? You need to think about that. And we've already talked about licensing issues. So VERDO, we like abbreviations. So VERDO is veterinary information required during outbreaks. And this is the first time we've had enough IPs, infected premises, to allow us to look at this, and get some useful information across the piece. Now, this 24 IPs is too little to analyze statistically in the way that we might do for other things, but it identifies the common risk factors and allows us to identify the themes. Now, these are largely circumstantial evidence, so we're not saying these were definitely the cause, but on the face of it, they seem the most likely causes. It also allows us to risk score premises and rank premises. Now, there's obviously confidentiality with different, with business information like this, so none of that is going to be displayed in this talk. But it also allows us to produce, in effect, a risk profile for the premises, and also to identify at a higher level the general trends in the different sectors. Now, this is the sort of information we get out of VERDO. You can't really see the detail there, but it just shows red, obviously, is where things are of concern. Now, bedding management. Now, managing bedding we think was a major contribution to quite a number of the IPs. There are plenty of simple things you can do to reduce your risk. You won't eliminate it, but you'll reduce it. So, storing bedding outside, unwrapped or with damaged wrapping, inadequate wrapping, will definitely increase your risk. It needs to be double wrapped. And before you move it into the housing, you need to discard the outer layer and cleanse and disinfect it. If you have damaged bales, you should discard them. And I think if you're operating a policy which is inherent in some production systems of topping up during the production cycle, if at all possible, you should be trying to move that bedding into the housing at the beginning of the production cycle, because that reduces the likelihood of you introducing infection into that group of birds. Now, obviously, for some birds like ducks, there's so much bedding used that would be impossible. The other feature we've seen is the use of mechanical straw choppers, which again are almost essential in some production systems. But what we've seen is that it appears to us that we've had massive point-in-time introductions of infection that spread throughout almost the entire shed, And we've put that down as possibly due to the fact that these have been contaminated straw has been introduced into the shed through a mechanical straw chopper, which has basically aerosolized a mist of infected virus within that bale. What we saw was no sort of mini epidemic the way we normally see with numbers increasing. We just got this blast of ill birds over most of the shed, and it seemed to coincide with those premises that were using straw choppers and not practicing particularly rigorous biosecurity. So just some examples. Everyone knows what straw bales look like, but there's bales being stored outside uncovered. There's bales that have been stored very well. They're inside. They're double wrapped. And here's a bale that has been, obviously opened up by birds. It's been, birds have access to it, and water can leak into it. And here we have, there's bird droppings on the outside of a bale. That doesn't look like much, but there are many infectious doses in that if that comes from an infected bird. And what you end up with is water pooling on the top, and that becomes a viral soup that if there are any holes in that will drain through into the bale and contaminate the bale, which will then be spread by either manually spreading in the house or using a straw chopper. Building design, there's some buildings are inherently less biosecure. Some production systems are inherently less biosecure, even when they're well maintained, and that's just because your normal management practices require things like ventilation. But you can see that even these high quality buildings, birds can come in and out quite easily, little wild birds, and even things like sometimes flaps are left open again for ventilation. But these are all valid risk pathways for bringing infection into the houses. Now, maintenance. This has been quite an eye-opener in this outbreak. You don't want to make your site attractive to wild birds and vermin. Roofs in particular are an issue, and moss as well. And for the first time, we've involved ornithologists extensively in most of the outbreaks, and they are adamant that moss is a really top attraction for birds. They come there for water, they come there for food, and if they're on your roof and you've got a leaking roof underneath that moss, you're going to be leaking virus through that roof. And we've seen IPs where the infection has started off in one place directly under a leak in the roof, and we can see the epidemic and the mortality spreading outwards from that point. Again, circumstantial evidence. It's not statistically robust, but there's enough. It's beyond reasonable doubt, I think. The fact that there's all the factors, everything adds up to it coming into that one point that is under a leaking roof. Same goes for holes in walls and air vents. This is equally important for many other diseases such as salmonella. And again, having doors with significant gaps or being left open allows the entry of wild birds. And we've had one incident, for example, in a previous AI outbreak where the internal doors separating the birds from the area where people were changing wouldn't close properly, and it was being blown open by the fans. And this allowed the birds to come out and roost in that service area overnight, where there were muddy feet, muddy boots, and they brought the infection into the shed because we had the infection, the actual epidemic started at the door and worked itself away from the door along the shed. Again, circumstantial evidence, but it seems to make the case. Everyone knows what a mossy roof looks like, but there's an example. And then some other basic maintenance. I mean, poorly maintained roofs. We actually had birds roosting up in there, and which made the culling and disposal operation very difficult. We have air vents and birds flying in and out of those. We have what looks like completely adequate wire covering that area down there on the bottom left. But if you look underneath, there are gaps that birds could get entry through. And then the bottom right is showing a roof with clear water staining all the way through it. So by locating your buildings, now I'm fully aware that locating a poultry enterprise is not straightforward. There's also planning issues and things like that, and just simply availability of suitable buildings. It was interesting that the majority of the infected premises that we looked at were within 100 meters of a significant water body, so not just a small pond. and a remarkable number had on-site water bodies. And in the case of free-range sites, some of them actually had the water body within the range, so enticing water birds into the area where the birds were. So if you have on-site water bodies, I think we'd encourage you to net them and fence them off to stop them becoming sites where other birds are encouraged to arrive at. Now, the other issue is wetlands and coastal sites, and we've had some of the IPs were actually underneath direct known flight paths from the landfill site to the coast, and so we'd have large numbers of birds crossing over the IP several times a day. I mean, from a disease point of view, that's like a high crime area. You'd be almost uninsurable if you lived in such an area, and it doesn't. It sounds idealistic, but if you're going to make a big investment in a site, it might be worth doing an ornithological survey and finding out what is in the area in terms of a bird population and the way it's behaving. But from all those things I've said about location, I'm fully aware the reality is things like planning permission, the fire brigade sometimes require water bodies on site to store water, and environmental planning conditions sometimes require water bodies as well. So I know it's a very complex area, but you can see you don't want to make your site attractive to birds that bring in infection. So here's an example. There's a large, very sophisticated establishment right beside a gravel pit with a large bird population. Now this is something that's interesting. I've talked about many of the things that we've looked at not being statistically significant, but in 2001 we had what was globally world-changing event of foot and mouth disease, which changed the way many governments throughout the world tackle foot and mouth disease. Now, we carried out a case control study there to look at the reasons why some premises became infected and others didn't. Often, the uninfected premises remained uninfected when they were very close to large areas of infection, and we wanted to know what was protective. We did a massive study looking at everything we could imagine, and at the end, we tacked on this extra question that said, when you turn up on the site, rank it good, medium, or bad, based on the mindset of the farmer and your general impression of the site. And that was the only feature in the entire case control study that was statistically significant. And I think the point I'd like to make here is that biosecurity, it's a bit like health and safety. It needs to be a culture. It needs to be set from the top down. And, that is what, that helps it become protective. And that was the lesson from 2001. It was these farmers who had the right mindset and valued biosecurity that managed to keep, in many cases, foot and mouth disease off their premises. And it's important that when you're doing biosecurity as a company, don't just do it. You've got to be seen to do it. And certainly I would expect any of our epi investigators, when they turn up on a farm, not just to do their full PPE check, but to be seen to be doing it. Don't hide around the back of the car. Do be seen that you're actually doing it, to show that we value the biosecurity precautions. So staff PPE, we talked about this, do the right thing, be seen to be doing it, including managers, dedicated PPE for all parts of the site. And we've talked about the individual sheds, not just the peripheral biosecurity, because don't forget that all that area between your sheds and in front of the sheds has got bird feces landing on it all the time. And you are going to be, if there's infection, AI virus in that area, you're potentially walking that into your sheds. So you need to be treating each individual shed as a biosecurity barrier, not just your peripheral fence around the whole business. Now, we had one interesting photo in one of our investigations where we got hold of an aerial photo which showed everybody standing around at some coffee break, having a fag or whatever, and you can see clearly that some are wearing indoor colour PPE and some are wearing outdoor colour PPE, and yet they're all outside. So it just needs that controlling mind discipline to say it's really important that you don't do things like this. It's a bit like egg collection rounds and gloves. We often come across people in egg collection rounds not using the gloves that are expected to be used under the SOPs. ABP, basically, good practice is important. It is attractive to birds, and it helps control the number of birds coming on the site. So here's two good examples, locked and covered skips, all enclosed, etc. All good practice. Staff facilities, we need good showers, they need to be properly designed and constructed. We sometimes come across investigations where we go in and there are staff in the buildings and the showers are dry. So, again, it's just making clear that, that has to be standard practice all the time. It's not all, obviously these are a few occasions, not saying that happens everywhere. Again, showers not being kept tidy or maintained, the whole place is cluttered. You need to make it easy to comply with the biosecurity requirements. So here's two good examples of changing areas and showers. So site maintenance, at the entrance gates, often poorly maintained, muddy, potholed. How are you going to do cleansing and disinfection at that entrance? Again, that entrance is what sets the standard for your site in a visitor's mind. Are you someone who takes it seriously or not? Don't have rubbish between your sheds and long grass. That encourages the rodents and the birds, and the ornithologists are very adamant about this. Don't have unlocked gates, don't have inadequate fencing. And interestingly, for rodent control, we always investigate this as part of our salmonella investigations or AI investigations. We generally find it's better done by outside contractors, as it's often one of the things that's forgotten down the priority list if it's been done by staff members. So here's just some examples of the sites between sheds, entrances. There's spilled feed in the snow, and you can see the bird footprints. They're obviously been attracted to that spilled feed, and there's more spilled feed within the shed. And some more examples of good practice, great fencing in the slide below on the bottom left, good entrance in the top left, and lots of lovely concrete on the top right. Flooding, now this is an interesting one. We've come across this as a source in several outbreaks over the years. It's a breach of biosecurity that really does require immediate action to clear up and prevent, because it's too late when it's happened. And basically it just washes a viral soup into your buildings from outside. And a couple of IPs where we've seen this, they've said to us, well, it happens quite often, but we just splash a bit of Virkon around. But that just isn't enough. It really is an ongoing risk to your business if you're in an area where flooding is occurring. Just showing some slides showing the flooding happening. And moving on to the visitors book. I mean, the visitors book for us is key tracing information. It helps us understand who's coming on and off your site, helps protect the rest of your integrated company. We really need all visitors to be recorded, as often they get very lax about whether your managers are recorded or staff members moving between sites. Often the detail is incomplete and it's often illegible. And again, it doesn't give us confidence in the sort of controlling mind who's setting the standards. And if we're doing an investigation, we will go for the precautionary principle as to whether visits had occurred or not. And if you're asking for licensing, the visitors book is a key part of our evidence for risk assessment. Hatcheries are good news. Basically, normal good practice in a hatchery, all the things you do to ensure hatchability are very effective at risk mitigation, and you've got an economic driver there to do all the right things. And especially if you're a designated hatchery, they're especially good. When we risk assess those, we often find the risk is completely is negligible or very low because of all the inherent control present. So record keeping, epidemiology, we need lots of data. We need to be able to do our source and spread tracings. We need to be able to do them rapidly. And these tracings drive the operational response. They help us get ahead of the outbreak so that it doesn't get out of hand. So how to help us? We need these records. We need them for a long time, so at least 3 months. We need them to be electronic so we can analyze them quickly. No whiteboards, please. We had one where the whiteboards only allowed 3 weeks of data, and they would erase the first week to take week 4. That wasn't very helpful. We need them taken at the same time of day, because egg production, if you're measuring at the end of one day and the beginning of another, it makes the interpretation very difficult. We'd like you to review your records yourself, because we found outbreaks where they were quite apparent from the records before they were reported, but they just weren't being reviewed often enough. We'd also like to have a description of your business. We'd like to understand how it works, because that way we can disturb you as little as possible when managers are busy dealing with culling and valuation, all those things in an outbreak. And it's quite important, we talked about the record keeping, do real-time graphing. I mean, every day, gather your data, put it on a graph, and that helps you spot trends very quickly and establish trigger points. And if they cross those trigger points, make the cells change color or something like that. Here's an example showing some data gathered for one of the outbreaks, and it shows well before we got the explosive outbreak, we had changes that were above the trigger points, and those changes are shown in red on the screen. Here's the tracings timeline we use to determine when the source of the infection could have been and when it could have spread off, and this helps us limit the tracings we're doing. And finally, the importance of biosecurity for contingency planning. It's important to contingency plan for how you would operate in the face of AI restrictions. I've talked about the sort of organic growth of businesses, and we all know that you tend to have on-site feed mills or associated hatcheries, egg packing stations, etc. So you need to think about, what you need to do to be able to cleanse and disinfect after you become an IP, how you're going to restock, and how you're going to provide the evidence we will need for licensing, for example, your hatchery to move eggs or things like that. So it's really important to think in advance for what are really big, complex businesses. Thank you.
Thanks very much, Andy. That was a really useful, practical session. And I'm sure, ladies and gentlemen, that leaves a lot of food for thought. I mean, we all love Ian Brown and his sort of great scientific knowledge, and and we need that. But having someone like Andy to be able to put across in very simple terms, the do's and the don'ts. And, we all think we have really good levels of biosecurity in our poultry industry. And to be fair, we do compared to many other industries. But as you saw from some of those photographs, there were holes in our systems, which, let's be quite frank, just simply should not have been there. So we move now, ladies and gentlemen, to our first discussion session. We've had a few questions come in. I have something just to say at the end before we go to our break, because we've identified a technical issue which we are correcting, and to enable you to ask more questions. So we have both Ian and Andy up on screen here. So if I can have the first question on screen, please. So this is from Helena Brewer, who's one of our industry vets. Do any low-path AIs have zoonotic risk, including non-notifiable strains? And I believe that is being aimed at Ian, please.
Okay, thank you. Good question. Generally, we have to consider any flu as potentially having zoonotic risk until we've proven it hasn't. But if we historically look at low-path, they tend to be of lower risk. We've had cases in the UK, back as 2007, we had H7N2 into humans, a small number of cases with mild infection. So it's not an absolute, they will carry zoonotic risk. They do tend to be low, but we have to respect them until we've had the time to analyse them. Just recently in China, they've been reporting some H10 cases in humans. So these would be non-notifiable AI in the UK. But there have been reported human infections. So I think we have to be respectful, but generally the high path ones are probably more dangerous from a zoonotic perspective.
Awareness, we work very closely during the outbreaks with public health colleagues, both at the central level, through the lab, and on the ground, because of course they are extremely interested in whether there is going to be a potential for a zoonotic outbreak. If we can have our next question up, please. What are the prospects for improvement of forecasting of migratory wild bird flu challenge, from Paul Mullen? Ian, I can maybe ask you this in the first instance from the global view, and then Andy may have any comments from in the ground perspective. Thanks.
Okay, it's a good question, and it's one we're grappling with. We can talk about doing wild bird surveillance and stamp collecting and trying to bring forward that decision-making process. That's what we're trying to do. And you're right, we tend to be a bit reactive. We've already got dead birds in the country before we find positives. Of course, we're beneficial in the UK. We're at the end of the flyway. So being connected with what's going on in Europe and elsewhere is really important, and that can give us a few weeks head start. EFSA have commissioned a small European pilot study to look at how we might do surveillance in wild birds with a true eye to getting early warning. So we've been pushing for this for about 5 or 6 years now. We started this off when we were a member country in the EURL. We were lobbying the Commission for thinking about doing surveillance in a different way. So we've actually right now got people on the ground, not actually APHA stuff, but we've got collaborators on the ground catching ducks in a large trap in Georgia. And we believe looking at strategically important wetland sites further to the east will be the clue to getting true early warning. Not the only way. So that's what the EFSA project is looking at. How can we change our thinking about how we do wild bird surveillance? We will still need the strands we've got in place, but we need to look at a more global scale in the right places. Everyone may be testing 30 or 40 birds in September in some of their local wetland sites. Might not be enough. We could miss the virus there. So we're looking for major events at major staging sites.
Thanks. Andy, I don't know if you have any comment from your EPI perspective.
Well, I think the main forecasting that we can contribute to is that we can sort of forecast which production systems tend to be the most susceptible, and maybe the production systems that ought to, have to up their game a bit, and some of the biosecurity measures that are for factors within their control that would substantially reduce their risk. And obviously there would need to be a discussion as to which of those were actually feasible from a business point of view, but I think many of them probably are.
Thanks.
Okay, brilliant. Thank you. Could I have the next question, please, on the screen? So what role do the farm assurance schemes have in enforcing the biosecurity standards? And that one is directed to Andy, please.
Right. I would say that farm assurance schemes should have a role. I mean, all the things that they do, they could look for the factors that we look for in our risk assessments. Now, it's up to the different farm assurance schemes as to how they would hopefully implement this, but we could certainly supply them with a list of risk factors that they should consider. But I mean, that's a judgment beyond epidemiology, really. But we could certainly supply the risk factors.
Okay, thank you.
Thanks. And the next question, please. Oops, I can't see. What are the plans for APHA's findings to be used to try to reduce the difficulties caused by other government advice and regulation? Andy, I think that's probably for you and me. I'm a bit trying to understand exactly where we're coming from in that one.
Yes, I think it's probably aimed at things like the provision of water on, for other, I think that I've been at meetings where it's been raised that there is a conflict between obviously the sort of issues that I was discussing today and the requirement to satisfy environmental regulations. And I don't know how we would use those. I don't necessarily think they're one to be traded off one against the other, but certainly there may be conflicting demands there. Yeah, I think that's probably where it's coming from.
Aha, I see. So not being an expert in any way on all the detail of environmental regulation, it's probably helpful to convey through your stakeholder groups what specifically the conflicts are, and then we can discuss them with environment colleagues. As Andy said, I don't think it would be about compromising one for the other. It'll be trying to get a cumulative impact and benefit on both aspects. But it would be good to understand more about those and how we can manage the biosecurity whilst also giving the environmental outcomes that are required. So do please, if you've got more information on those, provide it to your stakeholder representative and they'll send it in further.
Okay. So do we have any more questions? Here we go. There's one further one. Can farms be supplied with a template of all the information required by APHA? I guess this is another one directed at you, Andy, please.
Yes, and I think the simple answer is yes, and we've already done that in quite a number of cases where people have come to us, and we've provided them with pretty much what the information we need as soon as they become a report case, and we're starting our investigation. As I said to you, that this is a very difficult time, obviously, for you as the business, and you don't want to be bothered by us asking for information that can be prepared in advance, and that we can therefore access. So we've certainly got templates that we can supply, and we can work with stakeholders to find ways to get that out to you.
Thanks, Andy. And I'll just add to that, if I may, as a trade association, like other trade associations do, we are here to help you guys out there. And over the years, a lot of useful information has been able to be shared with colleagues around the industry. And there are sort of commercial operations out there who are prepared to literally hold your hand to cross T's and dot I's. And they advertise in the poultry press, as you will have seen. But, it is beholden upon us all to make sure that we are prepared. We all hope bird flu never comes, of course we do, but we have to be real here. And I think Ian has very clearly painted a picture of his scientific and veterinary colleagues as showing that risk level has increased, and it's going to increase potentially to be an annual event. Okay, ladies and gents, now I mentioned a few minutes ago that some of you are having, I've been told, have been having technical issues in being able to ask a question at the same time as watch the videos. So our techie colleagues have advised that the solution to this is to open another tab and then go into that tab with the same link at which you used to join this webinar today. And then you can ask your question. So you now have 15 minutes, ladies and gents, till 3:30 to have a comfort break and to send us some more questions in. So please join us at 3:30. Thank you.
selfish world that we've been given. Oh, can we try and help each other out? So la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. So what does it mean to be free? To be free in this American dream. Oh, help me believe life is more what we've been told. What we've been told. What we've been told. What we've been told. So la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. Be free. What does it mean? La la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. I'm a slave in the darkness, alone in my apartment. I should have seen the warning sign. Money don't come easy, so most of us are chained to being busy till we can earn a little piece of my mind. What does it mean to be free? To be free in this American dream. Oh, help me believe life is more than what we've been told it's supposed to be. Oh, la la let me be. La la let me be. La la let me be free. let me be. La la, let me be free. La la, let me be. La la, let me be. La la, let me be free. Be free. Poison me. La la, let me be. La la, let me be. La la, let me be free. La la, let me be. La la, let me be. La la, let me be free. I'm a slave in the darkness, alone in my apartment. I should have seen the warning sign. Money don't come easy, so most of us are chained to being busy till we can earn a little piece of my mind. What does it mean to be free? To be free in this American dream. Oh, help me believe life is more than what we've been told it's supposed to be. Oh, la la, let me be. La la, let me be. La la, let me be free. La la, let me be. La la, let me be. La la, let me be free. And it's such a mystery. We're still repeating our histories, even with the warning sign. Please help me out. Frustrated that this is the selfish world that we've been given. Oh, can we try and help each other out? So la la, let me be. La la, let me be. La la, let me be free. La la, let me be. La la, let me be. La la, let me be free. So what does it mean to be free? To be free in this American dream. Oh, help me believe life is more what we've been told. What we've been told. What we've been told. What we've been told. So la la, let me be. La la, let me be. La la, let me be free. La la, let me be. La la, let me be. La la, let me be free. Be free. Poison me. La la let, la la let me be. La la let, la la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. I'm a slave in the darkness, alone in my apartment. I should have seen the warning sign. Money don't come easy, so most of us are chained to being busy till we can earn a little piece of my mind. What does it mean to be free? To be free in this American dream. Oh, help me believe.
Welcome back, ladies and gentlemen, to the second part of this workshop. Just as a reminder, keep the questions coming. We've had a few over the break, but all are welcomed. And even if we don't get to cover all of them off now, we'll certainly do our best endeavours to get them answered and sent back to you after this event. So our third speaker this afternoon is Dana Simpson. So Dana was born in Israel and moved to the Netherlands when she was 10 years old. She always wanted to be a vet since 3 years old, and after a gap year after leaving school, travelling in New Zealand, Australia and Indonesia, Dana attended Utrecht University, where she achieved a master's degree in veterinary science in 2005. Dana was then offered a job at Erne Veterinary Group practice in County Fermanagh shortly after graduation and moved to Northern Ireland, where she practiced as a farm animal vet for 11 years. She started working with St. David's Poultry in 2017, with her main focus being on layers. Dana is a member of the Animal Health and Welfare Stakeholder Group in Northern Ireland, Animal Health Law Discussion Group, and is involved in an ongoing joint research project with AFBI and industry involving intestinal health in commercial egg layers. Dana works closely with DARA, providing training sessions, presentations to business development groups, and sample collections if required. Over to you, Dana, please.
Thank you very much. I'm glad to be here. My name's Dana, as was introduced, and I work at St. David's Poultry team in Northern Ireland. I was involved in the 2020 low-path AI outbreak in Northern Ireland, and I was asked to highlight some of the lessons learned and some of our experiences from the issues we came across at that time. Disease control challenge of non-notifiable low-path AI, which causes significant disease, sums up what I'll be talking about in the following slides. Avian influenza, as we know, is an infectious viral disease. It affects the respiratory and nervous system of the birds. Many bird species can be affected, and in the UK and Ireland, it's a notifiable disease. It can be split into two groups. You've got your high pathogenic avian influenza and your low pathogenic avian influenza. Generally, it is based on the clinical signs and the effects that the bird experienced once infected. Those different, there's so many different types and subtypes of the influenza virus that they are often grouped into H and N sequences or subtypes, with H being varied between number 1 and number 16, and the N varies between number 1 and number 9. So you can get a variety of combinations, which we see as a trend, and we can follow them then across their path across the world, often with the migratory birds. Out of those numbers, H5 and H7 are considered a high risk due to the opportunity of those viruses to infect humans and cause significant disease and mortality in people. So those two are the first subtypes we look for with a positive avian influenza case. The virus itself is secreted in saliva, nasal discharge, and feces. Infection spreads usually through contact, from bird-to-bird contact, and often through contact with infectious material. It has a varied incubation time. It could be anything from 2 days to 10 days, and clinical presentation varies with the different subtypes as well. I'll explain more about that in the next slide. So, disease spread and transmission, the most likely source of infection is directly from the wild bird population, most likely the waterfowl. We often encounter it in the migratory period when the waterfowl from across the world make their way down towards Great Britain and Ireland and Northern Ireland. However, the spread between the commercial farms is often found to be related to the movement of people, products, poultry manure and equipment. In this case, we've also come across spread following plumes and dust and litter that was created during on-farm culling using CGUs. In 2020, the first avian influenza positive farm was confirmed in a commercial flock in Northern Ireland. It was the first time in 34 years that we've had a commercial farm test positive. Although the strain was tested and found to be a low pathogenic strain, morbidity and mortality and the way it affected production was very significant for the affected flocks, and it had high mortality, severe production drops and a very high morbidity. It behaved, in fact, like a high pathogenic strain, but it typed as a low pathogenic strain. At the end, a total of 15 commercial sites from 5 different companies were confirmed positive during the outbreak at the start of 2020. Initially, when the first call came in, high mortality, I went out and did a postmortem on site where, with the findings, we suspected AI was a possibility. DAERA was notified and a veterinary representative was dispatched that evening to the site to take samples. In the meantime, restrictions were applied on the flock, cessation of all movements, people, birds, litter, everything was stopped onto that site at that point in time until further investigations were carried out. Following the veterinary government representative, samples were collected and further tested at the National Reference Laboratory. We received notification the following day that it was indeed positive for avian influenza, where then further testing was carried out and H5 and H7 variants were ruled out. At that point, it becomes the virus is then sent on to APHA for further typing to determine pathogenicity, and all restrictions remain in place on the farm. Following those actions, APHA tested the virus and found it was a low pathogenic strain. If we move on to the following slide, we'll see what the government involvements entail up to that point. So basically, when AI is suspected, we notify the department. Initially, a veterinary representative from the department comes out and collects samples and carries out the relevant tests. Site restrictions are put in place. Once the pathogenicity is confirmed, if it is confirmed as a low path AI, unless it's a H5 or H7 subtype, if any other type is confirmed as low path AI, there are no further government involvement. It becomes an industry led decision from that point on. If it is a high path virus that is detected on pathogenicity, the government takes over, prevention zone and positive surveillance zones are set up. Stamping out of the positive flocks is implemented. Any certification for movement of product or litter is then sorted by the government officials who are in charge, and it can have severe consequences for export, as many countries require a declaration of AI-free country in order to accept any exports of hatching eggs or any materials in that fashion. Following from that, we determined that the virus we were dealing with was indeed a low pathogenic avian influenza strain. It was identified as H6N1. In the next slide, I'll be showing what that meant for that farm in that situation. Once that result came through, it meant that the restrictions were lifted and the depletion of the affected flock isn't enforced by government, as it is a non-notifiable low path AI. The responsibility then falls to industry to manage quarantine of the flock and prevent the spread of that particular low pathogenic virus. In this case, the company involved decided to deplete the whole site, not just the affected house, but every house on that site, in order to try and contain the disease as best they could. During the outbreak that we experienced in 2020, there were two types of commercial farms affected. There were both commercial layer farms affected, both free range and cage systems, and broiler breeder units. The difference in clinical findings that we experienced was that the commercial layer unit findings, we had initially unusual droppings, loose droppings with a greenish tinge, subdued behavior, quieter birds, sick birds appearing. There was a large increase in number of seconds on those farms, mainly very weak shells, pale eggs, and a lot of jelly eggs were appearing. After a couple of days, mortality would start to increase, and drops in production that we were seeing were up to 90%. Some farms dropped to near no egg production at all. In the pictures, as you can see, top left, we've got a hen, a subdued hen, pale comb, just unhappy in herself. The eggs on the right-hand side show the variation in the shells that we could see. And as you can see, the loose droppings that were visible in the houses. When you go onto post-mortem, the findings were mainly involving the proventriculus and septicemia, and a lot of the birds had a fever prior to death, and that showed up in the post-mortem findings. In the broiler breeder, findings were slightly different. We initially saw a spike in mortality in the roosters, and they were shortly upon death, the wattles would discolor and the faces would discolor. They were very swollen eyelids and red around the eyelids, and they had a fever. That then progressed into a drop in feed intake, complete production cessation, and mortality could go up to 5 or 6% a day, which was significantly higher than in the commercial layers, and very high for that species of bird. The challenges we experienced, mainly from a veterinary perspective, it was different. We found that the disease manifested itself clinically very differently between the breeders and the layers, and even in different ages of birds. If you had a free range house or a cage unit, the spread within those houses, the time it took for the disease to go through was different. The recovery time in some of those flocks was very different. So it wasn't a one size fits all. There was a variety of presentations that was ultimately caused by the same initial viral infection. With depletion being optional and not enforced, meant that the initial cases were decided by the site owners in conjunction with their private veterinary practitioners on a case-by-case basis. The greater aim was always to protect the greater Northern Ireland egg and poultry meat industry. So that was always taken into account when the decision was being made whether to deplete a site or not. Other issues we had experienced, if we could move on there, we found that the cost was played quite a large part, as initially it was borne by the individual companies. It's very costly. A lot of the companies that were carrying this out were not in Northern Ireland or Ireland, so transport of equipment had to come across the water, gas canisters, catching teams. It was quite difficult to manage that, and the cost of it was quite very high. A lot of the smaller companies or independent laying sites or any independent farmers would have struggled to manage the cost of a depletion. Logistics was a problem. There was only a small number of available firms that were available to carry out the culling. There was a limited supply of gas canisters, so we were struggling to get sufficient gas for this. There's a shortage of catching crews. You need to imagine 15 farms were affected over a period of 2 months, but all the other work just continued on. So the catching teams were still moving pullets, were still catching birds for transfer or for going to the factories. So that was difficult to get hold of a catching crew at short notice. There was also a stand down period of personnel following depletion, with it being a notifiable disease. We tried to implement a minimum of 48 hours stand down time. So anyone on a team that was catching on a farm that was affected then had to stand down for 2 days. It made it quite difficult. Viral spread through contaminated material during on-farm slaughter with CGUs. This was all in the winter. There was very windy days. Feathers were flying, dust was flying, litter was flying. We discovered that was quite a high risk project, so that was something that we had to take into consideration. There was a large number of farms affected, which in return affected the whole industry because of exports being affected, egg numbers, broiler numbers, the restocking of the birds. Everything runs to a schedule. So if a farm is pulled out early, there are no birds ready to go into that farm. There was stand down periods for personnel, as previously discussed. There was quite lengthy cleaning and disinfection periods. It affected the industry in a much bigger way than just the 15 farms affected. For the farmer involved, it was a very traumatic experience, very emotional experience, and financially, with the farm all sitting empty for close to 7 or 8 months while it was being cleaned, disinfected, and ready to restock, that's quite a large loss of earnings. The mitigation strategies that we implemented, we decided early detection was always going to be key. So DAERA and industry, both the table egg and the poultry meat side industry representatives, and the private veterinary practitioners from Parklands Vets and St David's Poultry team all worked extremely well together. We all know each other. It's a small country. We all know each other, and we all worked together really well to get the information out as best we could to farmers, farm workers, backyard flock owners, to try and make everybody as vigilant as possible and report any early signs of disease in order to contain it as much as we could. Again, communication and cooperation between DAERA and the private veterinary practitioners, industry representatives, information was shared across the board in order to keep everyone in the loop. So across different companies, we kept each other informed on where the next outbreak was, so that we could act quicker and try and put in restrictions on farms close to the farm that was suspected at that point. for reduction of risk of spread with the on-farm depletions, we found that if we sprayed the modules with disinfectant spray prior to going into the gassing units, we reduced the plumage and the litter sort of blowing around by significant amounts, and that helped on the windy days to try and mitigate any sort of risk of additional spread. In addition, we placed a restriction on litter movement on the positive farms where the litter remained on site for 60 days and sprayed with disinfectant, this to allow the virus to be killed prior to moving the litter. There was extensive cleaning and disinfectant carried out on all affected sites, and only essential visitors on all the other sites in the vicinity were carried out, and a standout period of personnel was implemented. Now, what we picked out from all of that was that the different AI strains can have a different clinical presentation in different bird species and types. So we couldn't just look for the same signals and the same findings in all the birds. We had to sort of adapt to the fact that it could present itself in a variety of ways. During the migration period, AI should always be considered a possibility. Because of how it presents itself, it can sometimes seem not as significant or be more of a background thing with mild respiratory signs or something like that. But in that time frame of the migratory period, it should always be on our radar and should be checked out in order to make sure that we're not missing it in the early stages. Some strains of low pathogenicity can actually clinically present as high path, which is the case with the virus we incurred in 2020. Inter-farm movements of people, litter, equipment are all considered high risk and a potential spread factor in the spread of AI. We found that the plumage and even on-farm CGU usage can contribute significantly to the risk of spread because of the high amount of litter and feathers that are moving about. What we then discovered is that whole house gassing seemed to contain all the plumage and the litter and reduce the risk of spread during depletion significantly. And the leaving of the litter on site for 60 days, in addition, also helped reduce the risk of moving contaminated litter across the country. Communication and cooperation between all of us was paramount to getting on top of the issues we experienced and reducing the effects it had on the poultry industry in Northern Ireland. I'll finish up with the next slide. I can't commend DAERA and industry and the private practitioners enough. The excellent communication and teamwork really was essential in minimising the potentially devastating effect that the outbreak could have had in Northern Ireland. Without DAERA stepping in and taking over and helping the industry with the whole house gassing and providing people to help with the testing and just containing the disease, it could have been a completely different outcome. So we all worked really well together, and it paid off. Thank you very much for your attention. If there's any questions, please let me know.
Thank you very much, Dana, for a fantastic insight to the problems you had over in Northern Ireland. And of course, there were one or two cases on the mainland as well. And this resulted in industry asking for a low path procedure to be produced, which has been sort of launched and is in place at this current moment in time. Over to you, Christine.
Thanks, Mark. And it's probably worth just briefly noting, of course, people will be aware that animal health and welfare is a devolved matter. The administrations and politicians in those can make their own decisions, but we work very closely, massively closely together, because the science and the evidence is the same, and we appreciate that many companies work across all administrations, so that's key. Our next and final speaker for the workshop this afternoon really should be familiar, I hope, to many of you, and doesn't really need any introduction. I don't know where I'd be without Gordon, actually. It would have been a much harder winter. Gordon and his team worked phenomenal hours supporting the avian influenza outbreak, and also managing in the background various other outbreaks that you don't need to be concerned about here. Gordon is head of our exotic disease policy team, so he's responsible for our policy work on notifiable diseases of animals, also new and emerging animal diseases and surveillance policy. So a massive and critical portfolio there. This includes work on preparedness for outbreaks, and Gordon has a very strong background in that prior to this role, and is the animal disease lead for cross-government resilience and capabilities, which is very effective in feeding in the potential impacts and seriousness and importance of exotic disease outbreaks in animals in the centre of government. So I'm sure we're going to have a really informative talk from that policy perspective, which should join up the full circle we've been round from the lab, EPI in the field, hearing about veterinary practitioners' view and now the policy view. Over to you, Gordon. Thanks.
Good afternoon, everyone. I'm Gordon Hickman. I'm the head of the exotic disease control team in DEFRA. And this afternoon, I'm going to talk about some of the lessons from the 2021 outbreak, some issues related to EU exit, and to talk a little bit about the OIE chapter changes and the opportunities and challenges that they bring for improved control of notifiable avian diseases. I'm going to briefly review the 2020-21 HPAI and low-path AI outbreaks, look at the lessons identified from my perspective, then go on to look at EU exit challenges and opportunities, and then look at the OIE chapter changes and what that means to us, and then some next steps. So I'm not going to go through this in great detail because I'm sure that Andy has picked up on many of these things, but just out of context, the 2020-21 series of outbreaks were the largest outbreaks that the UK has known. And technically speaking, we were dealing with 4 concurrent strains. We declared the first infected premises on the 2nd of November 2020, and the last case was confirmed on the 1st of April 2021. We've just recently been able to self-declare country freedom from the 3rd of September, and that means that the duration of the outbreak was 305 days, i.e. just over 10 months. So a significant impact on industry. So we had 26 cases in total, 22 of H5N8, highly pathogenic avian influenza, 2 of HPAI H5N1, and a case of H5N2 low path AI, and another case of H5N3 low path AI. So not only was it the largest AI outbreak, but it was also the most geographically distributed. So we had a case in Wales, in Scotland, 2 in Northern Ireland, and the rest in England. And importantly, the outbreak affected a very wide range of production systems and premises types. So if you remember the 16-17 outbreak, roughly 50% were commercial and 50% were in backyard poultry. In this case, actually nearly 70% of the outbreaks were in commercial premises, 12 in large commercial poultry units in turkeys, ducks, broilers, and in layers, and 2 in house commercial game birds. 5 were in smaller scale commercial units, and by commercial we're saying at least 50 birds kept for commercial purposes. 3 in backyard poultry, and 4 in what we call captive birds, so not poultry. Interestingly, 2 in birds of prey, 1 in a rescue centre, and 1 in a wildlife wetland centre. Also, we found a significant number of wild bird findings, more than we've ever recorded in a single season. Over 311 tested positive at over 70 sites in, I think it's now 26 species, findings in England, Scotland and Wales. And this is just a slide showing roughly where they are. All of the outbreaks have been written up, and as Andy has gone through in great detail, highlighting the biosecurity areas. But if you want to look in more detail at each of them, you can look at gov.uk. What is interesting, I think, or important to note is that all of the IPs, the conclusion is that they were attributed to direct or indirect initial introductions from wild birds. So in these cases, wild birds is believed to be the source of all of these cases. And because of the control measures we put in place, we're pleased to say that there is no evidence of long distance spread between the premises in this particular outbreak. And the only cases where there was any evidence of spread was where it was part of the same business, and that the geographic distance was very short. Thank you. Just a reminder of some of the things that we put in place. So when it was clear that the risk had increased, we put in place what we call an avian influenza prevention zone. That was put in at a GB level, so in effect 3 separate AIPZs, and shortly followed afterwards by a zone in Northern Ireland. And when the risk increased still further, we put in place housing measures, i.e. mandatory housing for all outdoor birds from the 14th of December. Those housing measures were lifted on the 31st of March, but we kept in place the AIPZ with enhanced mandatory biosecurity measures with some access to outdoor areas on the 31st of March. And the zone was finally lifted on the 15th of May. We also banned all shows and gatherings on the 14th of December, and we allowed some low-risk gatherings to commence on the 21st of April, and then all of the shows and gatherings were allowed from that date in May. Just a reminder that all of our measures are based on risk, and we publish all of those risks. At the height, the risk of incursion into wild birds was assessed as being very high. It's now currently low, hence we don't have any of those additional preventive measures in place. And the risk of exposure to poultry is also currently low, but at its peak it was high. So I'm now going to move on to some of the observations and lessons identified. And I've tried to split these up into some themes, but I think firstly, in terms of processes and structures, the challenges to APHA and to the policy teams was around working within the context of COVID. So we had issues with staff availability, compliance with the various restrictions, access to premises where people were isolating, and also our historical ways of working were to get together physically. We had to totally change the way we operate so that we could actually manage the outbreak virtually. Fortunately, we'd also done a lot of prior contingency planning, and so using Teams and Zoom, etc., we were able to work through that on a virtual basis. Pleased to say that there was very good collaboration between policy teams and with our operational and delivery partners. And I want to highlight the key role that the Notifiable Avian Disease core group played in that, as being our trusted advisors, working with us to ensure that the measures were effective, but also least impactful. I think also there was a lot of evidence of suboptimal biosecurity on many premises, and perhaps a perception that in some cases the biosecurity was focused on procedures rather than infrastructure. But Andy's spoken a lot about that already, so I won't dwell on that. In terms of communication, I think we learned a lot about using social media and using webinars such as this to communicate more effectively than perhaps face-to-face or historical teleconference type forms of communication. We also used focus groups much more and targeted comms to different stakeholder groups where perhaps their interests were different or their challenges were different. Another lesson that we've learned is the absolute importance of having a single point of contact in large integrated companies. We were very conscious that in the early days, integrated companies were being approached by a large number of different people from APHA and the policy teams. So that's a key lesson that we want to embed. Another, I think, is the important role of vets in not only communicating biosecurity, but also in reminding keepers of the importance of early reporting of suspect disease, particularly in the face of outbreaks or heightened risk. So in terms of things that we need to do better going forward, more engagement with rescue centres and captive breeding sites. We need to work more with backyard flocks, and there is the continuing debate about voluntary versus mandatory registration and how we best communicate with backyard flocks. We've got some new campaigns planned, perhaps using more focused Facebook type messaging. And we also want to focus on targeted comms to birds of prey keepers. We were very struck by the fact that a number of those birds of prey keepers thought that by freezing wild shot birds, that they would somehow destroy the virus. There's more work to be done on legislation and policy, how we use AIPZ for communicating risk and facilitating enforcement. We need to look at some of the legislation in light of on-farm developments, such as on-farm hatching, and of course the new trading relationship with the EU and Northern Ireland. There were some initial teething problems, but there was good cooperation, and we worked through that as the outbreak went on. We also need to review the H5N1 in poultry and wild bird legislation. An area we also want to look at is guidance for keepers. It was clear from a number of cases that valuation and compensation wasn't well understood, and we need to put out some more guidance on cleansing and disinfection, in particular sequence of activities, perhaps where outdoor ranges are involved, and it's important to make sure that you get the 56 days or fallow of those zones, those outdoor ranges, started at the earliest opportunity. There are also some issues with IT interfaces, need to update data quickly, and to make sure that there is a single accessible for all admins and APHA to access risk assessments and licensing templates. Thank you. So now I want to just talk a little bit about the EU exit challenges and opportunities. So, as you'll be aware, the transition period ended partway through the outbreak. And so that meant we moved from being what was in effect a member state to being a third country. Also, during the outbreak, the EU animal health regulations came into force, so changing the legislative basis within the EU. Just a reminder, at a GB level, we've retained the original pre-1st of January legislation. The new animal health regulation controls are broadly equivalent to our current domestic legislations, but arguably they're actually less flexible. So we're not going to immediately move to implement them, but there have been a number of changes that we've made to facilitate trade with the EU. Also, just to note that low-path AI is still listed at the EU level, as it is in the UK, but it's no longer a category A or B disease. So what are those challenges that are brought? Well, firstly, whilst the EU have recognised PZs and SZ zoning for regionalisation, now we're a third country, we need to demonstrate enhanced surveillance throughout that entire 10-kilometre restricted zone. And that duration for that surveillance is 90 days, whereas previously the restricted zone, the PZSZ, was lifted after 30 days, and trade could continue from that zone after that 30-day period. We now have an additional 60 days where trade with the EU is restricted. The changes have also created a significant additional amount of work for policy teams and APHA, and we now also need to do that enhanced surveillance. So we've identified all of the backyard premises in the whole of that 10-kilometre zone. We've also made a couple of avian diseases listed. So avian mycoplasmosis is now a listed disease, as is avian chlamydiosis in citizens, so those are parrots and things like that. The EU exit has brought around changes to the export health certification. Those new export health certificates will need to be used from the 15th of January next year. Also, just a reminder that for any of you exporting, the requirements for approved establishments have changed, and as a result, we've updated the poultry health scheme to reflect those new measures. Also, one of the next things what we'll be needing to look at is the use of laboratories undertaking official activities. So that's testing for EU export, testing for the poultry health scheme, to be designated as official labs. There are, I think, some opportunities to streamline the process, to further reduce that sort of air gap between us confirming disease and the EU making their legislative changes and going through SCOPAF. And I think there's an opportunity to discuss potentially removing or reducing the 90-day restricted zone requirement for those restricted areas. I don't think that'll happen anytime soon, but we will be engaging with the EU to pursue that. And I think longer term, there are also options to discuss disease control for low-path AI. Moving on to the OIE chapter changes, perhaps some better news here. So there were some changes made to the OIE code on avian influenza in the May 2021 general session. So firstly, the flock level incubation period was changed. The duration for self-declaration of country freedom was reduced. The definition of poultry has changed, and low-path AI is no longer an OIE listed disease. So in a little bit more detail, so the incubation period at the flock level has reduced from 21 days to 14 days. Now the good news there is that we may have scope to reduce the back tracing of product that is already on the water. So working with our trading partners, we may be able to reduce the impact of AI on some of our trade that was already in stream, if you like, before disease was confirmed. Another really positive thing is that the period after final C&D on the last premises, after which we can self-declare country freedom, has been reduced from 90 days down to 28 days. So we've significantly benefited from that already, and we were able to self-declare country freedom from the 3rd of September, which would otherwise have been the 4th of November. So we've saved ourselves 60 days of trade restrictions. And that means our trade colleagues can now start to engage with those third countries that require country freedom before they'll trade with us. Perhaps in the longer term, we've also got an opportunity to look at the definition of poultry. So I've highlighted the key change there. So at the OIE level, birds that are kept in a single household and the products of which are only used in that household are not considered poultry by the OIE. So whilst at the EU level and the domestic level, chickens, turkeys, ducks, etc., that do produce eggs or meat are regarded as poultry. If that meat and eggs is solely consumed at the premises level, we've got some leverage when we're talking to trading partners when discussing regionalisation and trade impacts. And it means that when we declare those backyard flocks, we'll use terms like captive birds rather than poultry when we're describing the epidemiology. So really to conclude and with some next steps, I just want to reiterate the importance of contingency planning and business continuity planning. So we found from this outbreak that a large number of producers can be caught up in zones. So whilst the risk of you becoming an infected premises is relatively low, there is a much higher chance of you being caught up in a zone. And that means that you should have a contingency plan because you may not be able to move your birds to slaughter on the day that you'd originally planned. You may not be able to move table eggs to an egg packing centre. If you're caught up in a zone, you may not be able to move things like brood and move, because we can only license day-old chicks, point-of-lay pullets, and birds to slaughter. And even then, it will be on the basis of risk. Also, you can't release game birds in protection zones. You also need to be prepared for mandatory housing and the impacts that that will bring. And there could well be restrictions or bans on exports from affected areas for some time. And so I'd urge you to put in place those biosecurity plans because they will stand you in good stead, whatever the disruptive challenge, whether it be a fuel strike, a COVID-19 related restriction on an abattoir, or any other disruptive challenge. So what we'll be doing, working with industry, working with our core group colleagues, is looking to review our policy on legislation. Any changes in policy will be subject to engagement and consultation. We really want to embed those lessons identified, both in terms of process and guidance, working with industry and all poultry keepers to make sure that those contingency plans and business continuity plans are in place. We want to raise awareness of the threats as we move into the higher risk period. And today is an excellent example of how we're working together to deliver that. We want to actively involve and engage with the harder risk groups, backyard producers, rescue centres, captive bird keepers, etc. But not forgetting perhaps smaller commercial keepers. Highlight and communicate where biosecurity can be improved, and once again reinforce the need for ongoing vigilance. Thank you very much, and very happy to take any questions. Thank you.
Great, thank you very much, Gordon. That was really informative, even for me, and I hope for everybody else watching today. Key, of course, contingency plans, not just for when you have an outbreak, but when you're caught up in an outbreak or other incidents and things that happen unplanned. So there we are. Thanks, Gordon.
Okay, ladies and gents, we're going to move on now to our second discussion session. So all four speakers' faces will appear on your screen. So could I have the first question, please? So how effective do you think the AIPZ was? Did you model the outcome if you hadn't put one in place? And does your experience in 2020 change how you would implement one in the future? And that's from Graham Deere, who's chairman of BPC. And that, I believe, is aimed at Gordon.
Well, if I kick off, but I'll probably rely on Andy as well for sort of the epidemiological perspective. Like all of these things, you can never prove how effective it was. All we know is that, as I repeated, where we had confirmed cases, there was no, if you like, local spread from that. So a combination of the AIPZ and the restrictions through PZSZs are clearly being effective from that perspective. I do genuinely believe that the use of AIPZs, particularly the mandatory biosecurity, firstly gives us an opportunity to reinforce those biosecurity messages, not just to commercial producers, but in particular to those that aren't linked into organisations that have organised this webinar. And I think the extra tool of having the housing order, I'll call it the housing order, but the use of housing measures that we can bring in when the risk is particularly high, and when our risk assessment is that it would be beneficial, I think does help. In terms of how it worked, I think it worked particularly well working at a GB level. So we brought them in all together and we took them off all together. We didn't have England versus Wales, Wales versus Scotland, etc. I think that's a particularly powerful way of using this. And I think as we've gone through this, we've worked with the core group to, if you like, improve the measures within those AIPZs so that they are able to be enforced by our local authority and APHA colleagues. And it does give local authority colleagues the opportunity to better enforce biosecurity measures. So yes, I think they work well. I think we always base them on risk, and we always work closely with our core group colleagues in terms of, is now the right time? Are the measures that we're using right and proportionate?
Okay, so could I have the next question, please? So housing was very effective. Why do we just not have the housing order from the start of November rather than waiting for the first outbreaks? How can we deal with the challenge of duration? Are any improvements possible? I mean, it's probably one for you, Gordon, but I will put my two penneth worth in to start with, and it's quite simple, guys. We would run out of 16 weeks on our free-range hens, and therefore they would have to be marketed as barn. And commercially, that would be a disaster. Over to you, Gordon.
Yeah, it's a real balance as to when to bring this in. In the ideal world, we'd bring it in, 14 days before the first outbreak, because we might have actually prevented that first outbreak. Like all these things, and I think both Andy and Ian have both said there is never no risk. So it's a balance. We are, as I said before, evidence-based. We work very closely looking at what those risk factors are, and in a future year, there may be different risk factors. The wild bird I'll call it prevalent, but the rate of infection in wild birds may not be as geographically spread. So, there may be a different situation. Ian's already spoken about the different virus characteristics in terms of, how infectious they are in terms of dose before you get an impact. And whilst, yes, it was very effective, if you also house a whole bunch of birds, you get a whole load of welfare impacts potentially as well. So we just have to manage that. And I'm not going to say that, next year we'll put them in place in November and lift them in March. We reserve the right to leave them on for 20 weeks or 25 weeks or however long as the risk period is there. But as I say, we have our experts that advise us as policymakers as to when's the best time to put one in place.
Thank you, Gordon. Next question, please. So how do you think the low-path H6N1 virus spread from farm to farm, and especially between layer and broiler breeder sites, or is it just prevalent in wild birds in Northern Ireland? And this is from Stephen Lister and directed to Dana, please.
We actually had a very interesting, the first two cases, which were a broiler breeder farm and a cage layer unit, were both in the same area, only on probably a stone throw away from each other. And the disease started near enough within the same couple of days from on each other there. So there's a large pond area with waterfowl further down the road. This was in County Fermanagh, where there's a lot of water nearby. And we found that both those farms got it at the same time. And from that point onward, it seemed to sort of spread to the local farms mostly. Unfortunately, the large layer unit that was initially affected was also a processing plant. So there had been a vast amount of lorries from a variety of different packers that had come and gone to that site, making it quite difficult to ascertain where exactly or how exactly it spread. But we did link a lot of the spread to litter movements across certain paths where the disease emerged. But the initial ones came from wild birds in that same area, and after that, the more widespread cases appeared to be linked more to the movement of litter and the movement of birds. We also think that the initial depletion that we carried out on those two sites was done by CGUs. It was a really stormy week. And initially, when we were carrying out the depletion, the feathers were just flying and the litter was flying. So we think that may have had initially also spread it to the local farms in that area. So once we stopped doing that, once we started spraying the modules, that reduced significantly, and the spread was markedly reduced once we started doing the whole house gassing and containing that. And when we started keeping the litter on the affected sites for the 60 days, that made a very big difference as well. So we think, as well as the wild birds, we think the litter was a big spread to the further away cases and the plumage and stuff to the closer premises.
Okay. Thank you, Dana. And I'd invite other colleagues on the panel to speak, but I'm just conscious we just wanted to get this final question in, if we may, because we wanted to share something right at the end of this session with you. So this is from Keith Warner, one of our industry vets. How can we get agreement for movement licensing for brood and move meat and turkey, breeding turkeys and chickens, and the new process on-farm hatching is currently allowed for laying pullets? So I suppose, Gordon, this naturally falls to you, but other colleagues might just want to comment on this.
Well, I suppose the first thing is to say the reason we can't license is that it would be against the law to license it. And so whilst it's unlikely that you guys would challenge it, other people could. So in order to change it, we would need to make a legislative change. I think, however, we just need to look at yes, the UK or GB or England could make a change, but it's also not permitted in the EU. And in fact, the EU restrictions under the new animal health regs are even more restrictive than the current regulations in terms of things like restocking of poultry within PZs and SZs. So we've got to be really careful that we don't just change something because it would be convenient for us to change and have a significant impact in terms of our ability to trade, because we can no longer evidence that our risk measure, our controls are, I use the word equivalent, but similar to those that are in place already at the EU level or with our major trading partners. Anything that is seen as a change or a reduction in the rigor of our control measures will be looked at very carefully. I mean, that said, you're absolutely right. I can't see a difference between the risk factor of moving an equivalent old aged turkey poult to a pullet. So I fully understand that, and we will look at the pros and cons of that, but we cannot legally license them now.
Okay. I'm conscious that time is running away with us. We've got literally 3 minutes overtime, which we are allowed. So what I'd like to do now is just share a couple of slides with you, if I may, if those could be put up on the screen, please. Okay, so what we thought was, we've had these 4 excellent papers together, and I'm sure, your heads are probably going round and round in circles with all the information that's come out. So we've pulled a number of take-home messages together. So clearly, biosecurity is always going to be number one. But as was explained by Andy, is having a clear company or farm AI prevention strategy and procedures in place, which management leads on. Because if management leads, staff follow. And as I remember, an industry colleague said to me just 2 or 3 weeks ago on a totally unrelated subject, if you've got showers on your site, then you have to make them inviting enough for your staff to want to use them. In other words, not having cold water, etc. Third point, maintenance strategy for sites and buildings on them. No leaking roofs, etc. Try and minimise the risk of flooding. Then, of course, keeping the external fomites opportunities for down. And then, of course, the actual farm environment as well. Is it fit for purpose? And I hate to say this, guys, but, we are in an increased risk period now as we move into the 2020s from bird flu. And those people who have a parcel of land close to a water source, realistically may not be able to put poultry on them in the future. And I'm talking the industry won't allow it in terms of a broiler integrator or an egg packer, etc. So if we go to the next page, I'm not going to go through this. We haven't got time today, but we will email this out to all of you after this event, and we'll update it slightly in the light of what's come out of the presentations. So on that point, could I just pass across to Christine, please, who would like to say a few words?
Thank you very much, Mark, and thank you very much to all our speakers and for those listening in today. I found it hugely informative, even although I went through the last AI season as Chief Vet. The point for me is we're always learning. Every outbreak is different, even if it's the same pathogen, because it's about how it works on your farm, in your flock, that is important, and therefore understanding that and the measures that will work for you are really important. We continue to watch globally through our international disease monitoring team how bird flu is spreading and working around the world. We do preliminary outbreak assessments and publish those online and share them with information with industry. So do keep watching out for the changing risk as we go into this next winter period. Thank you.
And ladies and gents, I hope what's been shared with you this afternoon can help you keep bird flu out of your businesses and, of course, in turn, the country, because we know what happens when we lose our country freedom. It costs us a fortune in terms of lost trade. So let's raise the biosecurity bar still further. And thank you very much and good afternoon to you all.
Supposed to be. Oh, la la let me be. La la let me be. La la let me be free. La la let me be. La la let me be. La la let me be free. And it's such a mystery. We're still repeating our histories, even with a warning sign. Please help.